Hi, so I'm gonna record two different videos. The first one is going to be from a distance so you can see the marble come down. And the second one is gonna be from up close using my phone. Enjoy. So the first thing I want to discuss is the potential and kinetic energy in this roller coaster. So as I drop the ball, since there is no force acting upon the ball except for me dropping it, that is the potential energy as if it were going up. The kinetic energy is when the marble is rolling down the hills, and when it gets to the loop, that portion is potential energy because it's going back down, and then it goes all the way down, so it's kinetic energy on the way down. Hello, so I'm just gonna go over a couple more things about my coaster. When I was filming it, I didn't realize I needed to talk while I was filming it, so I'm gonna be incorporating voiceovers throughout my presentation. So first I want to talk about the first law of motion. When an object is in motion, it stays in motion unless it's acted upon by an outside force. In this case, which you'll see an up close of my roller coaster in the next digital slide, is that I drop the marble, it goes down, and the force acting upon it is the centripetal force when it's spinning, and it's rolling friction. So there is friction as it's going down the roller coaster, but it's rolling friction, so it's not as intense. The second law of Newton says the more force that there is on an object, the faster it will accelerate. So I believe that my marble didn't accelerate super fast is because there wasn't a big force on it. I kind of just dropped it, versus when you're on an actual roller coaster and it zooms up and then it goes down because it's being pushed. I don't know if you've ever been on the ride The Hulk at Universal Studios, but that one is full acceleration for the first portion of it, and then the drops with the potential energy as it flips upside down help with the kinetic energy. And then for every action, there's an equal and opposite reaction. So as the ball is pushing down the roller coaster, it's kind of making a force along the track, which also helps slow it down. So another thing that is important with this roller coaster project is gravity. So gravity kind of makes things stay down. It's the attraction of force between all objects. And with gravity, there's terminal velocity, which is the force of gravity and air opposing it. So because the marble is light, it has less gravity than, say, a bowling ball or something the mass of a bowling ball. Everything has the same, so the mass of an object can be the same, but weight determines the gravity. So if I had a marble on Earth that weighed a little bit more than the marble I used, it might have accelerated faster because of the terminal velocity. So here is your up close view of my roller coaster. As you notice, in Newton's first law of motion, object in motion will stay in motion unless acted upon by another force. The force in this case is inertia. There is inertia when it changes directions, as you see in the second half of the loop. So I wanted to add on to the end of this video because I didn't get to talk about my experience that much throughout the video. I was looking down just for references for my notes. One thing that I noticed during this project is if you go back and you take a look at my video, I had to include a cover on certain portions of the roller coaster for the safety features. Those portions were so the marble wouldn't bounce. I found that those were for when I was changing directions or changing the movement. And I think that had a lot to play on the marble slowing down because it was a change in the direction. It was a change in the movement. It made the marble shift. It made it slow down. Another issue that I had was getting just the right slope for the kinetic energy to get the ball to go around the loop and to get that centripetal force to pick up. It was challenging to make sure that the ball was safely going upside down and not falling apart. This experiment took a lot of trial and error, and I did look at the simulation beforehand to try to figure out what type of slopes would be best. in order to best apply Isaac Newton's 3 laws of motions. I think this is something that I could definitely use in my classroom in the upcoming year, but I might have to break it down into multiple sections like the woman does in the teaching channel video. She has the students lay out a groundwork of what they want their coaster to look like. Then she makes them do the online simulation, and then she gives them the ability to do it in class. I think that if I am able to have my students fully understand the vocabulary and the concepts, this would be a great way for them to gain an deeper understanding into this concept. And I really loved how in the teaching channel video that she incorporated both math and science together. I teach both math and science together, and I could incorporate this into my classroom very easily because energy is a big part of my curriculum. So I hope you enjoyed my reflection video. As you read through my lab, some of the stuff will be similar to what I stated, but I hope that all the roller coasters are interesting, and thank you for taking your time to watch my video.